We'll start. Okay. So good evening, guys. So in this session we are going to see motion in a plane. Okay. Yeah. Yeah, like we'll see once again the motion in a plane, projectile motion as well as relative motion, and we'll solve the problems as well. Okay. So the first thing, motion in a plane. So in last classes we have seen first straight lines, which is one dimensional. So plane is nothing but it's a two dimensional. So both x axis and y axis will plays a major role in this. Okay. And whatever the equations we have seen in kinematics, no, like kinematic equations, the same equations which we are going to apply in this cases also, but we'll take separately horizontal component and vertical components. Okay. So basic things is we need to know about what is vectors, which we have completed in basic math, right now. So the thing is here the components of vector we'll see. Okay, components of vector in x axis as well as y axis. Okay. So for example, when I take a plane, an object has been thrown in a plane with some u velocity. Okay. So in this cases both x and y axis takes place. I need to take separately for x axis as well as for y axis. Okay. This u has been thrown with some angle theta with respect to horizontal, will say, like theta is with respect to horizontal, no, like x axis. If theta is with respect to vertical, that is y axis, you should take. Okay, this is y axis and this x axis, this is u. Got it? Now you can keep in mind, whenever theta is close to the axis, that is cos theta, away from the axis is sin theta. Here theta is close to which axis? X axis. So ux will be equals to u cos theta, and whereas uy will be equals to u sin theta. So in other cases this theta is close to y axis and away from x axis. So what I should take? Ux, yeah, it is u sin theta, and this one uy will be equals to u cos theta. Got it? You can take this. Done? Okay. So as of now we know the velocities. Now the thing is acceleration thing. Okay. Now acceleration, when I throw the object with some velocity, it is coming in other side of the surface. It is due to gravity, we can say, no. If I throw the object to the sky, obviously it will reach some highest point and again it will come down. So what is acting there? Like gravitational force is acting there to pull that, to push that object towards down. right now. So acceleration direction will be towards down, that is this is my g, and I am throwing the object away from, against the acceleration. So what is the acceleration I should consider? Minus g. Okay, this is the thing. So what are the things we got now as of now? Ux will be equals to u cos theta and uy will be equals to u sin theta, right now. This is the thing, yeah, with respect to horizontal, this condition. Okay, I am throwing the object away, against the gravity, so ay will be equals to minus g. What about ax? Is there any gravity acting in this surface in horizontal direction? No, it is 0, right now. Now we came to know that what are the velocities and what are the acceleration in the case of horizontal, with respect to horizontal. Okay, yeah,
might be plus g also
while coming down, but you are throwing against the gravity. No, that's it. You are throwing against the gravity means obviously a will be minus g.
Then when coming down it will be plus, or
like, yeah, that is for the next case. We'll see when you are throwing the object from the height h, simply like you are leaving the object. In that case, what we will take? Like if you are leaving object like this, like due to the gravity it's going down, like free falling body we have studied now. In that case, plus g will take. Okay, now first thing, vertical. Okay, vertical component, okay, and horizontal component. So what is vertical component? Y, no, vertical component, so y axis. So what are the equations we know? V is equals to u plus at, v square minus u square equals to 2as, and s is equals to ut plus of at square. Okay, now whatever the equation is there, I will take in terms of y. Okay, so velocity y, like final velocity in y direction, should be equals to initial velocity in y direction plus acceleration in y direction and time t. Okay, next I will take the first equation, I will substitute the values now. Okay, now the thing what we know is, when I throw the object, no, I will take a big diagram here. Object will reach like this, it is a parabolic path. So there will be some height h, this is maximum height reached by the object, and there is some displacement happen there, like distance. So this is range, we will say. In x direction we will say range, in y direction we will say maximum height. Okay, now to reach the maximum height, what will happen to the velocity? It becomes 0. Yes, no, it becomes 0. Like Vy will be 0 at h max. Yes, like what here we can understand, no, when it's going to the top of the point, no, velocity goes on decreasing, and again from top the point to the bottom point keeps on increasing. Yes, no. Okay, now 0 is equals to uy, what is uy here? U sin theta, no, u sin theta plus minus g into t. Okay, take this u sin theta this side, so minus u sin theta is equals to minus gt, where minus minus gets cancelled out, so t will be equals to u sin theta by g. This is for reaching the maximum height. No, we have calculated for reaching maximum height. So to reach maximum height, time is u sin theta by g. Again to come down, the same time will take, no. So how much it is? 2 u sin theta by g. Okay, we can take that. So t is equals to, yes, we will complete, wait, first one we have completed, second one will go, third one also we will see. So if you listen here, so this one will be small t and small t. So total I will take a capital T, which is nothing but total time. Okay. So which is nothing but time of flight is nothing but 2u sin theta by g. Okay. So in one dimensional we have seen the total time is total time of flight 2u by g. Here the angle is made because of that inclined. Okay, going with some angle. Okay, it's sin 30. So sin theta. Done? Okay. So for vertical, first one we completed. We'll go for the second one. So what's the second equation? B square. Second equation is v square minus u square equals to 2as. So s is nothing but the displacement happen in y direction, that is h max. Okay. So this is vy, uy and ay and sy. Okay. Now what is vy? It's 0. Velocity in y direction, that's final velocity, is 0 square minus u sin theta the whole square is equals to 2 into minus g into h max. Got it? H max. Now what will happen? I can take this out. No need of 0. So minus u square sin square theta is equals to minus 2g h max, where minus and minus gets cancelled out. So maximum height will be u square sin square theta by 2g. Okay. Muhammad Taha. Hello. Done? Now in the third equation, s is equals to ut plus of 80 square. No, in this case, like to find the maximum height only, same thing. Yes, no. In this case, what I can do? uy, like velocity, initial velocity in y direction will be u sin theta. T we have found out. What is t here? T is equals to u sin theta by g. To go for the maximum height, it is u sin theta by g. Yes, no. Substitute the value. And of a into t square. Okay, I'll do here. Completed this one? Yes. Okay. So third equation, what they are saying is, yes, displacement in y direction should be equals to velocity in y direction, that is initial velocity and time, plus of a acceleration in y direction and t square. Right now, so h max. Maximum height should be equals to u sin theta into, this is u sin theta only, no? Yes, no? By g will come, plus 1 by 2 into minus g into this one u sin theta by 2 g the whole square. Okay. So this is the thing. So when I solve, we'll get the same answer. For previous case, what we got? U square sin square theta by 2g. This also will get the same answer. Okay. What will happen here? U square sin square theta by g. Okay. And here minus, here g square will come, 1g and 1g will get cancelled out, so minus u square sin square theta by 2g will come. Okay, 1 minus of how much? 1 by 2 will come, no? So obviously we will get the same answer. I will do here, u square sin square theta by g minus, I have taken minus as it is, so g and g will get cancelled, I will keep g here, okay, g u square sin square theta by 2g, g and g square, g and g will get cancelled out, remaining how much? If I take commonly outside u square sin square theta by g, 1 minus 1 by 2 will be remaining, u square sin square theta by g commonly outside, 1 minus 1 by 2, which is nothing but 1 by 2. So same answer we are getting now.
U square sin square theta by 2g.
Got it? So what we got now? Two things we got, time of flight and then maximum height. Now we will go for the horizontal component, which is nothing but the range. Completed? You can note down this first. Done. Okay. So this thing we have completed. Now the remaining thing is in horizontal component. Okay. Horizontal component, which is x axis. So what is the first equation? V is equals to u plus at. So in terms of x axis I will take. So velocity, final velocity in x axis should be equals to initial velocity in x axis plus acceleration is in x axis and time. Okay. Now what we will find here? Like what are the things we know? U we know, a we know. Okay. So what we will get? Velocity, final velocity in x axis will be equals to u cos theta plus 0. So which is nothing but velocity in x direction will be same as initial velocity, like final velocity is nothing but initial velocity in x axis. Okay. So one thing we can get here, whenever it's going in this path, no, y velocity keeps on changing, but x velocity remains constant throughout the motion. Okay, it's keep on changing, and again if velocity, total velocity becomes 0, like in both x axis and y axis, body will fall down. Yes, no, but velocity of x axis is there, that's why it's coming down again. Okay, so what happens here in this point, velocity of final velocity of y axis will become 0, but final velocity of x axis will be same only, initial velocity only. Okay, so when it's going in this direction it is positive, but after that the object will turn around, so it will become, here it is positive only, final velocity of x axis, but for the y axis it becomes negative. Okay, some questions they can ask, for example, velocity is given as, like initial velocity is given as u is equals to 2i plus 3j. What is the final velocity of the object when it reaches the other side of the ground? Okay, so which is nothing but v is equals to 2i minus 3j. Okay, velocity in x axis remains constant only, but in y axis it gets reversed. Okay, this one thing you can note down. So u will be equals to uxi plus uyj, then v will be equals to vxi minus vyj. Note this point. His voice is not audible. Okay, done.
Second problem.
Vx, like velocity, final velocity in x direction square minus initial velocity is equals to 2 into
As 2a
v square minus u square equals to 2as, no, 2 into a into s. Range, no, this one. Okay, fine. Now what will happen here? Final velocity I don't know, I keep as it is. Initial velocity I know, that is nothing but u cos theta the whole square, which should be equal to 2 times of 0 into range. So total value becomes 0. I can neglect that. So v x square should be equals to u cos theta the whole square. Square and square will get cancelled. Am I getting the same thing now? Final velocity is nothing but the initial velocity of the given object in x axis. That's for the second equation, no? Okay, we'll go for the next equation. So S is equals to ut plus of at square, where this is range, right? So range is equals to velocity, like initial velocity in x direction into t plus 1 by 2 into 0. Yes, no? Yeah, 0 into t square. Okay. So what is t now? Time. T is equals to u sin theta by g we got, no? Yes, no? So the time of flight we should take here, because like the total time we should calculate, no, like the time is taken to reach h is, that is u sin theta by g, but to reach again r is 2u sin theta by g. Now substitute the value. What is velocity in x direction? That is u cos theta, which is into 2u sin theta by g. So can I write like this? 2 times of u square sin theta cos theta by g, where 2u sin I mean 2 sin theta cos theta can be written as sin 2 theta. Okay. Now the range formula will be u square sin 2 theta by g. This is my range formula. Okay. Got it? Done? So now equation of trajectory we will see. Okay. So up to now what are the formulas we got? Range we got. Time to reach maximum height we got. Okay, maximum height we got. Total time, which is nothing but time of flight we'll say. Okay. Done. Next, H max we got. So 4 things we got. Okay. So what are the formulas first for the first one? U square. Yeah, u square sin 2 theta by g. And for the second one, u sin theta by g, time of flight is 2u sin theta by g, h max is u square sin square theta by 2g. Okay. Now equation of trajectory we will say. So equation of trajectory in the sense like in terms of both x and y axis we will take. Okay. So for that we will take s is equals to ut plus of at square. Okay. In terms of y we will take in y direction, y is equals to, okay, y is equals to u, what is u sin theta I should take, no? U sin theta into t plus 1 by 2 into minus g into t square. What is t? Time of flight. But time of flight is I should take in terms of total x axis. But to reach maximum height, what is the time? U sin theta by g. Okay. I should substitute the value there. Okay. Then we will get the equation of trajectory. So equation of trajectory is nothing but equation of trajectory, equation in both x and y axis. Okay. Got the equation, or we'll solve that equation? Okay, we'll solve the equation. See, now the same, what I have told, s is equals to ut plus of at square. Okay. Now what will happen here? Y will be equals to uy t plus of ay t square. Similarly for x will be equals to ux t plus of ax t square. Okay. Now we will substitute the values whatever we know. Okay. So uy we know, ux we know, right now, and yeah. So first one we will take y will be equals to u sin theta t plus 1 by 2 into minus g into t square. This thing I know. For the second one, what will happen? X is equals to u cos theta t plus 0. Total value will become 0 because ax is 0. So multiplied by anything will become 0. So total 0. Now what I will do is, from this equation I will take t is equals to x by u cos theta. Okay. Now substitute the value of t here. Got it now? So y will be y equals to u sin theta into what is t? X by u cos theta. X by u, sorry, this x by u cos theta minus it is. So
minus g by 2
minus g by 2 into t square. No, what is t square? Again x by u cos theta the whole square. Got it? Got no? Yes. Yeah, here u and u will get cancelled. X tan theta will come. Sin theta by cos theta will become tan theta minus g x square by 2u square cos square theta, which is nothing but equation of trajectory in terms of y and x. Okay. So now we will solve some questions regarding this topic. Done right? Okay. Let's start with the question. The maximum height attained by the ball projected with speed 20 meter per second at an angle 45 degree with horizontal is. Now before doing the question, no, I will say one point. Okay. When we talk about the angles, no, like initially from 0 to 90 we can say, yes, no, 0 means in horizontal direction, that is one dimensional, but 90 in the sense in the vertical. In between whatever angle it will go in plane, right? No. So what happens here is, like when the angle increases up to 45, again it will go down. So maximum height attained by an object or maximum range attained by the object when angle is 45 degree. Okay, when angle is 45 degree. For that what we do is, we take angle 0, 30, 45, 60, 90, everything will substitute. Okay. For example, we will take u is equals to 10 meter per second and we will substitute those values and we will get what is the height and what is the range. Okay. So in that what we are getting is theta will be equals to 45 degree where it reaches h max as well as range, both are maximum. Okay. Now come to the question, you can take this point.